Yeah, boys and girls, today's lesson is lesson 7-3, and it is called Fractions of Different Size Wholes, meaning the whole thing, different size wholes. But quickly, I want to refresh something from yesterday, something I feel like I missed a little bit. When we're talking about a number line, I guess I don't need to write the arrows at the end. I'll just make it go from 1 to 2. Or sorry, 0 to 1. If we have one spot in the middle, these would each be halves, right? If I added 2 more spots, then we'd have fourths. So we'd have, sorry, I should probably not make this a half here. They would each be halves, but here is the half point. Okay, if I did put it in fourths, that would be 1/4. This would be 2/4. This would be 3/4. Just because I put it in halves first doesn't mean I can't still measure in halves when I change it to fourths. Because sometimes you'll see stuff like this. You'll see it in eighths, to where this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and obviously the last one's 8/8 or 1. So this is where you could find equivalent fractions, because the way I have them lined up, you know that 2/8 and 1/4 are equivalent. You know 2/4, 1/2, and 4/8 are equivalent. You know 3/4 and 6/8 are equivalent. You know that 5/8 is bigger than 1/4. I know they have different denominators, but you're able to see that from this bar graph. You know that 7/8 is bigger than a half, just by looking at this bar graph. So I know yesterday we talked as if it were just one denominator all the way through, because we really did have it like that. By adding more lines, adding more options, you can do whatever you want with it. You can look at it and say, I want to go in fourths, so I just want to look at this chunk, this chunk, this chunk, and this chunk. Those are fourths. If you want to go in eighths, you go in the eighths. You follow all 8 chunks. If you just want to go with a half, you just do the to the halfway point. So that's something I feel like I missed out on yesterday, and by looking at your lesson or the homework, I think it's something I definitely want to go over in small groups. So understand that for this lesson. All right. So today we're going to compare fractions of different size wholes. It says John and his 5 friends want sandwiches. They make 2 sandwiches, one on a short loaf of bread and one on a longer loaf of bread. John cuts each sandwich into 6 pieces. His friends think the pieces are not the same size. Are John's friends correct? Explain. Well, I'm not going to write it in there, but are John's friends correct? Absolutely they're correct, because when you have one sub bigger than the other, like if I were to take this and break it into 6 pieces, 1, 2, 3, 4, 5, 6, they should be equal, they're not exactly, and 1, 2, 3, 4, 5, 6, they're exactly right. Besides this bad piece here, because I made it look so big, these pieces are really going to be smaller than each of these. If you had a pizza the size of our room, okay, if you made a pizza the size of a room and you cut it into 4 pieces, and then you made the pizza the size of a quarter and cut it into 4 pieces, sure, each of them is 1/4 of the pizza, but when they're different size wholes, it makes up a huge difference. So the next question is, what can John do to make sure all of his friends, everyone, gets the same amount of food? Well, there's 6 people, if I think right. John and his 5 friends, so 6 people, are going to cut each sandwich into 6 pieces. So what do you think would make it fair? If there's 6 pieces on the big one and 6 pieces on the little one, if each of his friends all get the same amount, what would be the fair way? What would be the equal? What would be the fairest way to make it all equal? Hopefully you said, well, each person gets one of each sandwich. There's the first person, second person, third person, fourth person, fifth person, and then John. That way they each got 1/6 of the big one, the big sandwich, and 1/6 of the small sandwich. So they didn't technically get 2/6 because we're talking about two different wholes here. But they did get 1/6 of each whole. Next question. Hattie's dad ordered one small, one medium, and one large pizza. He divides each pizza into 8 equal pieces. Hattie takes 1/8 of the small pizza, and her friend takes 1/8 of the large pizza. Hattie says she has less pizza than her friend. Is she correct? Explain. Put an answer there. Yes, no, why? Well, hopefully you put yes, she is correct. Because Hattie got a piece of the small pizza, which would be that big of a piece, and her friend got a piece of the big pizza, which is that big of a piece. So absolutely, she is right. She got less pizza than her friend. Hopefully she's not upset about it, but she got less than her friend because her friend took 1/8 of the bigger pizza. So what do these problems tell us about fractions? Well, what they tell us about fractions is that fractions change, the amount of the fraction, the size of the fraction change based on the size of the whole. Okay, so if the whole is huge and you cut it into half, you get a big chunk. If the whole is tiny and you cut it in half, it's still going to be tiny. So imagine me. Imagine taking my shoes and cutting my shoes into halves. Okay, and then I took a pair of your shoes and cut your shoes into halves. Our shoes are each in halves, but here's the difference. Here's your shoe. Okay, maybe I should make that my shoe. I'll make that your shoe. And here's my shoe. Okay, put some laces in there and make it actually look like a shoe. And here's where the socks would go. Or really hairy ankles, 1 and 2. But anyways, if I took half of my shoe and you took half of your shoe, obviously my half would be way bigger than your half just because of the size of the whole. So always understand that when it comes to fractions, just because you have 1/2 or 1/8 of something, it doesn't really make that much of a difference or doesn't show how equal something might be unless you're comparing it to that fraction of another whole that's the exact same size. All right. So I'm going to get my shoes out of the way that didn't turn out really looking like shoes. And I'm going to go over 1, maybe 2 of these with you, and then I want you to work on the rest on your own. So number 5, a shelter had 4 spaniel puppies and 6 beagle puppies. Jack adopted 1/2 of the spaniel puppies, and Carmen adopted 1/2 of the beagle puppies. Who adopted more puppies? How do you know? Well, if you want to draw over here, you could say, okay, 4 spaniel puppies. So we can go 1, 2, 3, 4, and I'll put an S in there for spaniel. And there were 6 beagle puppies. 3, 4, 5, 6. So B for beagle. Okay, and it says Jack adopted half of the spaniels, so Jack took half of the spaniels, and Carmen adopted half of the beagle. So she took half of the beagles, half of 6. So who adopted more puppies? Well, Carmen adopted more because half of the whole of 6 is 3. Half of the whole of 4 is only 2. So Carmen adopted more puppies. She has 3, and Jack only has 2. So number 6, it says Julio planted 16 daisies and 10 sunflowers. His neighbor's goat ate 5 daisies and ate 5 sunflowers. Did the goat eat a greater fractional part of the daisies or the sunflowers? Explain. Well, the goat ate 5 of the 16 daisies and 5 of the 10 sunflowers. So which fractional part was greater that she ate? Well, you can tell that 5/10 is bigger than 5/16. So the goat ate a bigger fractional part of the sunflowers. Because there were only 10 and she ate 5. The daisies, there were 16, and she ate 5. So there's still 11 left over. The sunflowers are down to 5 now. So we're going to continue working on this in a small group. This whole lesson this whole unit is kind of spread out. It's the same concepts you're trying to learn, but they're kind of spread out throughout the lessons. So it's something we're going to get. I feel like we're getting there. So if you have time, work on 7 and 8. If you finish those, work on the pages prior, and then we will talk more about it in small group.